it has
And
been
then
going this long.
Yeah,
this show has.
this
Yes.
is episode 860 of Floss Weekly. It's
Yeah.
been around for a very long time. Yes. Yeah, we have a lot of fun.
That's amazing. Awesome job.
Yeah, it used to be part of twit.tv with Leo Laporte. In fact, Leo was the co-host of it for a while.
Mm-hmm.
And then they had to kind of make some changes to they had to make some business changes to be able to continue doing business. And one of the things that they had to do was let go of Floss Weekly. And so I came over to Hackaday where I was doing writing, and I said, hey, I know a great podcast that needs a home. And my editor there was kind enough to go to bat for me, and we ended up coming over to Hackaday. So he's
Nice.
it's a lot of fun. All right, we are live on the internet, by the way. Let me
Yay.
get that link, put it into our Discord, and then we can get started.
Oh, let's see. I show up in the chat window here, right? In case we need to chat.
Yeah, we can do that.
Yeah. Okay.
Right. Okay, so the way this will work is I'll start the show here in just a second. I'll bring Randall on, and we will talk for just a couple of minutes about essentially what we think the show is going to be about. We'll catch up a little bit 'cause we haven't talked to each other on the show for several months now, so there'll be a little bit of banter. And then we'll introduce you, we'll bring you on, and then we'll dive in and talk about Elixir and all of the Erlang stuff that's going on. We'll go for probably 45 minutes to an hour with you, and then at the very end we sort of do the same thing in reverse. We'll dismiss you from the show, but you can stay on the call and chat with us afterwards. That'll be fine. Yeah, I think that's it. So I'm going to start hitting the buttons, and we will do the thing. Yeah. It'll be fine. It'll be fine. All right, here we go. Hey folks, it is time for Floss Weekly. That's the show about free, Libre, and open source software. I am your host, Jonathan Bennett, and today we are talking about Elixir and Erlang and probably a lot of other things going on in that community. We haven't talked to him for a couple of months, I think, and so it was time to bring him back. And really what happened is a listener pinged me and said, hey, this guy, you need to have this guy on. All right, we will have that guy on. And that guy is Jose Valim. We're going to bring on here in just a moment. But before we do that, we have a co-host. What was the thing we always used to say? A beautiful and talented co-host? Is that the way it went, Randall?
I can't remember, but it's something, I think, something about beautiful. I remember that was sort of snuck in there as I would introduce the various
that was part of the
co-hosts,
spiel,
yes.
because I remember every time you would introduce me when I was co-hosting, I just sort of had a pause. It's like, I don't know how I feel about this, but it's good to be here. Welcome back, Randall.
Hey, thanks for having me back.
Yeah. We were comparing notes before the show got started about a lot of different things. But what's is there anything new in your world that you want to sort of give a brief update on? We'll let you plug stuff at the very end. But what have you been up to recently?
Just basically taking care of Dart and Flutter things, because that's sort of my primary bent at these days. I've been a Flutter Google Developer Expert, one of 10 in the U.S., for about 6 years now, 6.5 years. And so that means I get to spend a lot of time online answering questions for people and doing virtual presentations at Google developer groups all over the world. But that's mostly what I've been doing, that and answering questions. I've also been playing with AI tools, in particular anti-gravity, and having a lot of fun working with that to develop software and update software and to review other people's software. Anti-gravity has been fascinating in the approach there, and I can't believe it's free still. So that's the best part, is free.
Yeah, free is good. I've recently dipped my toes into those waters, and just getting an LLM into VS Code and letting it look at some things, and I have been amazed it goes back and forth. I will either be amazed by how good it is and it predicts the thing that I want to do and it gives me good code suggestions, or it's terrible and has absolutely no idea what's going on. It seems like it can only do those two extreme opposites.
Yeah, I long ago turned off autocomplete. I don't use it for autocomplete anymore. I basically use it as a command-driven
Right.
code updater. So I'm basically giving instructions as a prompt and letting it change my code agentically based on that. And that seems to be a lot more effective for me than autocomplete.
Right.
So I haven't actually. It's been weird because in the last 6 months, the amount of time I've spent actually coding, I think, is completely different. I don't find myself coding as much as instructing agents to code for me. Using good software engineering practices like create a PRD first and then create a test plan for every step that you change, things like that. And if you use good software engineering practices, the current models, especially now, Gemini 3 Flash, is fast and does reasonably well at coding practices, and that's built in, of course, to anti-gravity. And so I've been getting a lot of good work from that. So that's kind of what I'm experimenting mostly with these days.
Yeah. Well, I've got a note here that our guest is actually also doing some experimentation with AI stuff, and so we'll have to ask him about that. Let's go ahead and bring him on. Actually, Jose Valim, welcome, sir, to the show. And I've got a brief bio here. He is the creator of the Elixir programming language, chief adoption officer at Dashbit. It's a company that does sustainable open source and continuous adoption for Elixir. You are a seasoned speaker. You've done 3 programming books now, obviously a member of the open source community. And you're also involved with Tidewave.ai, which we might get to as well. Welcome, Jose, to the show.
Hi, thank you for having me. I do have a question. Are the guests beautiful as well, or only the co-hosts?
I don't think I ever used that with guests. I think I only used it with co-hosts. It was just a random, beautiful and talented whoever, right? It was just a stupid thing to say to bring people on.
Yo, it was fun. Still is fun. We have a lot of fun here. I sometimes before the show I'll tell guests when they come on, just imagine that we're 3 new friends sitting down geeking out over something, and that's always sort of the vibe the show has had.
Yeah,
So
exactly.
that's what we're here for.
Fantastic.
All right, Jose, tell me about Elixir. Now we've talked about Erlang and Elixir on the show a bit before, but you're a different voice because you created Elixir, and so let's do sort of a brief catch up. Like what is the Elixir language and what problem is it solving? But then let's also go into like, what's the origin story? At what point did you wake up and go, I need to make a programming language based off of Erlang?
Right. Do I start with the story or with the elevator pitch?
Whichever one you think makes the most sense.
Okay, so let's go the long way on this.
All right.
All right, so we'll have to go. I'll try to be brief. We'll have to go a little bit back in time. So this was about. So if we go back 15 years, 16 years, right? Like a lot of programming languages were coming up at the time, and those languages that were showing up, right? They all had concurrency as one of the features, right? So like Go, Clojure, right? Like every language that was showing up, Rust later on, they were thinking about concurrency as part of the problems that they want to solve. And that's because it was about that time that when we realized that our computers would not magically get twice faster, right, every 2 years. And we started to have machines with 2 cores, 4 cores. Like today you can get a machine and run in production with 40 cores, right, 64. I like to say even your wristwatch has 4 cores.
Yeah.
And so people realized that, well, they started to think, well, if now we need to be able to write software that is going to use all the cores on your machine efficiently. And that's where a lot of people were at the time, like, how can we improve, how can we write software that is going to use all the resources, all the cores in our machine, and if I run it in a machine with 2 cores, it's going to be twice faster, but if I run on a machine with 8 cores, it's going to be 8 times faster. So
If only,
that
if
was,
only it was that easy.
it can be, right, or it can get pretty close to that. So we are getting to part of the elevator pitch already, but
Yes.
so, and that's where I put myself in, right, at the time. So at the time I was doing Ruby, and I was part of the Rails web framework core team, and we started running through some concurrency issues because we wanted, like everybody, to use all cores. And then I was like, wait, like, if concurrency is going to become important, because that's what everybody was talking about at the time, 2 cores, 4 cores, 16 cores, how can I write software that is going to, as I said, it doesn't feel easy. How can we write software where concurrency is going to feel easy and is going to feel natural? So I didn't start with, like, let's create a new programming language. I think hopefully most people don't when they have a problem. They're like, I know, I will create a new programming language. So I started with the purpose to learn. Okay, so I was like, okay, let me see. Somebody has to have solved this problem, right? And I started exploring, learning different languages, and I like to say that in this journey, there are like two things that changed, like, rewired my brain, changed how I think about software. Which is, the first was when I found functional programming, because a lot of the and functional programming means many things to different people. So I'm going to say it's when I found immutability, because a lot of the programming languages that we use, why concurrency is hard, is because, well, you have a thing in memory, like an array, an object, whatever, right? You have this thing in memory, and now you're like, well, let me try to use 2 cores. So you have 2 cores running at the same time, and I imagine that they want to change the same place in memory, right? If you're not careful about that, right, one is going to start changing the thing in memory, is going to race with the other one, you get a segmentation fault or a race condition, and your software doesn't work, right? So you have to, that's why concurrency is hard, right? Because you have your memory and you have your piece of code that is doing an operation, and you have to think about how all those different threads can interleave each other and get to that piece of code. Very hard to reason about it. And um, so, but the thing about functional programming, but to me, really immutability, is that, well, what if instead of if I have an array in memory or an object or whatever, what if instead of change it in memory, I just create a new one? I never really mutate things. I treat things as immutable, right? So if I have a list, I want to remove an element from that list, I get a new list, right? I don't change the old one. And if you do that, something very simple, very straightforward, a lot of the concurrency issues that I had to deal with, boom, they disappeared, right? And it's like, it's the best way, I like to say it's the best way of solving a problem, because sometimes you have a problem and you have to solve it, right? So you go and you have a solution, but you have like the problem and the solution coexisting. But with immutability, it's like it eliminates the problem. Like the problem is no longer there; it's gone. It's not like you have to think about true mental models. It just doesn't happen. And then when I found that, I was like, "This is great," right? And I like to say that even when trying to think about software, immutability is fantastic, because in many programming languages, because everything is mutable, you can change everything. Like, you call like a method passing an argument, and then at the end of that method call, your argument changed, but it was not clear that it changed, right? Because there's nothing in the function, in the method signature that denotes that. But anyway, immutability was the first thing. And the second thing was when I found the Erlang virtual machine. So I'm already going to your other question, which is, so why Erlang, right? And the reason was, So I was learning about many different programming languages, right? Like at the time, seeing how they do concurrency, Scala, Go, Haskell. I was really exploring everything, Clojure, everything you could learn and how to solve those different problems. And then I found Erlang. And the beautiful thing about Erlang is that, so again, 15 years ago, everybody was trying to solve the concurrency problem. And the reason we want to solve the concurrency problem is because if I'm running software on my machine and my machine has 4 cores, I want to choose all cores. But what happens when you're running that software? 4 cores are no longer enough, right? Like you need more CPUs, you need more memory, right? You can maybe get a bigger machine, but you can also get another machine, right? Now you have to scale horizontally. So now your problem that originally was running on a single machine, now it's running on 2 machines, and your problem became a distributed problem. And the beautiful thing about Erlang is that Erlang not only solved the concurrency issue, but it also solved the next problem, which is like, well, how do you write software that needs to operate on multiple machines and coordinate and communicate over multiple machines? And to the cherry on the top is that Erlang not only solved those problems, it solved those problems in the 80s, right? So it's like everybody's like, hey, how do we solve this thing? And Erlang was like, well, I solved the current problem, I solved the next problem, and I did it like 3 decades ago. And for me, I say like it was love at the first sight. I'm going to have a break here because maybe you have questions, check how we are, and then we can go back.
Yeah, the you call it immutability. It's very similar to the copy on write concept, which that's more of a file system concept, but it's sort of the same thing. Let's not modify the actual thing. Let's make a copy of it first and work on that. It seems like you would still run into the problem of trying to reconcile your various copies. Certainly, that must be a thing.
So you have all the copies, right? So if you have so imagine that you have a list, you're doing multiple operations on the list. Every time it's a copy, of course the language is going to optimize and say, hey, that copy is no longer used. So maybe I'm going to just to garbage collect it. A smart compiler is going to know that you no longer use it and is going to change in place. But you as a developer, you always think that you have copies. That's the mental model. And then if you have multiple copies, you can keep them in memory and then you can look at both at the same time if you need. But it becomes like part of the programming model. You don't really need to reconcile. Like if you want to use the old one, you use. If you want to use the new one, you use because they're all there as you need it.
Interesting.
So you're using Erlang, the VM, the actual core guts. Are you also using Erlang the language still, or is that sort of just over in the corner somewhere?
Right. So that's an excellent question. So let's talk about Erlang. So I talk about like how Erlang does concurrency and distribution, and but it's really like it's the thing that attracted me and the thing that made me fall in love with Erlang. But once we go into Erlang, it's really full of wonders, right? Because so what is Erlang? So Erlang is a programming language. It is a virtual machine that was created by Ericsson, which is a telecommunication company. And they created Erlang because they wanted to build things like telephone switches, right? And if you get a telephone switch, right, you're going to deploy it somewhere, right? You're going to write the software, deploy it somewhere. And that thing needs to be very robust, right? It's basic infrastructure, right? Like everybody's going to depend on it. And it needs to be concurrent, right? Because you're going to have hundreds of thousands, millions of calls coming to the same switch. And then, well, it needs to be distributed because you don't have a switch to deal with the whole world, right? You have you deploy several switches around the world. So they need to be able to communicate with each other. So, and then it also needs to be resilient because, like, again, it's infrastructure, right? Like, if something goes wrong, it needs to be able to heal itself and go back to a working state. So when they were designing Erlang, they were thinking about all those problems and how to implement a programming language at a runtime that is going to naturally solve all of those things. And they even solved things like, I like to say, like, we don't have, we don't, in the past, we didn't receive phone calls, not today, from our phone operator and say, hey, we are going to be in maintenance mode from midnight until 1, so please don't use your phone, right? So in the language, they have a mechanism for updating the code that is running live in production without dropping connections because they had to solve all those problems. So, and then they went ahead and they solved those things and all those wonderful properties. And the thing is that, and the other thing that made me fall in love with Erlang is that if you get this design well of the telephone switch is something that needs to deal with multiple connections at the same time. Information is coming going all the time. It has to be distributed. That's pretty much every web app that you write today, right? It has to talk to the database. It's going to receive a bunch of connections from phone, from the browser, web sockets, right? So that's the other thing. Like Erlang started to have, it's from the 80s. It started to have a resurgence around like 2007, 2008, exactly because a lot of people realized that, well, you know, if they solve that for telecommunications, it's going to be really good for the web, right? And that's what makes Erlang still shine today. So one of the biggest use cases is WhatsApp, right? WhatsApp runs on Erlang, and they run at a massive scale. They have more than 1 billion users, right? They, like 5 years ago, even more, they said they have more messages going for WhatsApp than the whole SMS system. So it's like, it's a massive scale, and it's running on Erlang. So to answer your question, so they designed, like, the Erlang VM is not really like you cannot get the Erlang VM and implement any programming language you want with it. If you want to have something that has all those properties, like it's concurrent, it's fault tolerant, you need to make like design decisions that focus on that, on immutability, on isolation. So anything that runs on the Erlang virtual machine, like, has to be a sibling to Erlang. It's not like it cannot diverge too much.
Sure.
So
it has to be an Erlang adjacent language.
Yes. Right.
yes, it's not like you can go like from, like, let's say like Java to Clojure, where they, you know, they feel like very different languages, right? You can't go that far apart in Erlang. So and so, like, when I started Elixir, my first prototype, I did one prototype that failed, and one of the mistakes was exactly not embracing Erlang. So today, when you're running Elixir, you're writing Elixir. You don't have to learn Erlang to write Elixir. And I would say the majority of Elixir developers, they don't know Erlang, but the concepts are the same. The way you think about writing software, the way you think about resiliency, about concurrency, the data types, they are the same. So they are very, very close.
Yeah.
Semantically.
So I'm old school Smalltalk. So I worked with the Smalltalk 80 image on in 1981 on a Tektronix 68,000 based graphic display. So I've been doing Smalltalk for years, and one of the things that attracted me to Smalltalk and it helped me understand object-oriented programming better is the idea of these objects essentially being somewhat, in some sense, independent. I mean, if you look at Alan Kay's original vision for Smalltalk, it was that he sort of projected forward to the idea of like agents, that they were all independent little agents. And the thing though in Smalltalk is all synchronous message sending though. So you send a message, you wait for the response, and that those are all synchronous. There are options for forking and stuff, but mostly it's all synchronous. As I understand it, Erlang is sort of more Alan Kay's original vision of independent agents operating with asynchronous message passing. Can you describe that for our audience better?
Yeah, that's That's a very good question, and and there are some debates that happen exactly on this topic. Um, and I like to think that Smalltalk and Erlang, in many ways, they are like two sides of the same coin. So let's talk about how. So let's say like after this, I'm like, okay, let me give Elixir a try. And so how do you have to think about writing software in Elixir? So in Elixir, all of your code runs inside processes. And when I say processes here, it's not the operating system process. Those are very cheap, lightweight thread of executions. Like you can literally create a million of them. So so you create a million of those, right? And that's exactly right. And that's how you get concurrency because you have all those processes and they are all running at the same time. And if they need to communicate with each other, they do it by sending asynchronous messages, right? So they're like, hey, I wanted to do something, and then the thing will potentially do that thing. It's going to reply, right? So they are sending messages to each other. So message passing is the main way of communication. And what else can we say about this? And the processes, they are isolated, right? And this is very important. So for example, when I'm describing this system, somebody can think, oh, so that's similar to Go and Go routines. And yes, it's similar to Go and Go routines, but in Elixir, in Erlang really, all the processes, they are isolated from each other. And this is very important because imagine that you have two processes and they have a shared state, okay? So this process can go change this state, this other process can go change this state. What happens if one of these process crashes? Well, if they have a shared state and one of the process crashes, can you guarantee that when that process crashed, it didn't leave the state in a corrupted place? Like maybe it's supposed to like think about it like a in a database, right? If we have a database or changing a table, sometimes we need transactions, right? Because we need to do all changes consistently, right? So, well, if we have shared state and two processes change that thing, how can we guarantee that the state's not corrupted? So that's what they were thinking. So going back like to what we were talking about, when they were designing Erlang, they were not like, hey, we need a functional programming language. They were like, we need immutability because if our software, if we don't have shared state, um, it means that we can write resilient software. So what we have in Erlang is because all the processes are isolated, if a process crashes, you can just go, like we have this thing called supervisors, which are other processes that go and say, hey, that process crashed. Let me start a new one. So this whole idea of like how do you write a system where all the entities are isolated and when things crash we can start a new one, it's all baked into the language and it's part of this processing model how you think about software. And like similar to Smalltalk, because in Smalltalk one of the things people liked, people say like what caused like a positive impression and gave them a good experience is also like you have like the, I don't know the exact name, but I would say the IDE that would allow you to see and inspect all of the objects and understand what is happening. And Erlang is the same because everything is running processes. Like you can go and say, hey, what is this process? What is doing right now? What is the state? So in that way, it feels like very similar to objects in Smalltalk in the sense that you have a great deal of introspection and you can send messages to it, but it's more at a higher level in the sense that the process has its own data and that data is completely internal and then they are async. And just one last thing, because I get too excited about this, is that so we're talking about processes, right? That they can exchange messages with each other, right? And they're all running concurrently. So that's how we get concurrency. And you know how we get distribution? We basically run the process on another machine, and because they communicate by message passing, the Erlang virtual machine abstracts the message passing for you. So it doesn't matter if the process they are running on the same machine or a different one, they can talk to each other, and it works transparently. So a lot of the times, like I am like working on a software and I'm like, hey, what if I need this distributed? I have to change 3 lines of code, 4 lines of code, right? In most, like the huge majority of other languages, 99% of other languages, if you write a software that is concurrent, right? Even simple, like imagine that you start writing a web app, right? And for simplicity, it's a chat app, right? So users can go and send messages to each other. If you have a single server, that's very easy, right? Because you keep the room in memory, you have all the sockets on the same machine. When somebody sends a message, you send to all other users, right? But now you're like, oh, I want to deploy to two servers because you want like some fault tolerance in there in case one machine crashes. Now you have users connected to two different machines. How they're going to talk to each other. You have like to fully redesign the solution, right? You have to start from scratch, right? And Elixir Erlang is the only languages that really allow you to say, hey, I did this thing, it's concurrent, now I want to make it distributed, and it almost just works, right? You have to revisit some assumptions, but the foundation is the same.
Wow.
Something else I wanted to touch on is you also work with a program called Plug. I think maybe you created that one as well. What is
Yes.
Plug, and how does it tie in here?
Yeah, so Elixir came as a programming language, right? And then I knew that at the beginning, one of my responsibilities was to, after the programming language is there, is like, well, what are we going to use this programming language for? And because I came from web development, I knew that um, Elixir was going to naturally be used from the web because the people I reached out to, they were doing web development. So we have a web framework today called Phoenix, and Plug is it's basically an abstraction for building web applications. Like it's a building block. So like pretty much all programming languages or many programming languages, they have like multiple web servers, right? Like I'm not going to be able to give examples in other languages, but I know in Java you may have Caddy and then you may have something else. Go probably has a few different ones. So Plug is just an interface that says, hey, if you want to be a web server and you want it to be able to serve web applications, this is the contract that you have to fulfill. This is how your application should look like, and now everybody can run. So it's a very basic building block for web apps.
And that works natively on top of Elixir as well, right? It's all
Yeah.
tied into the same. Yeah.
Yeah.
I'm sort of curious about, given the concurrency, given that you've got thousands, millions possibly of independent executing agents running processes. Um, how do you orchestrate things like that? I mean, that must be part of the complication of working with Elixir is the orchestration level required. I mean, I'm trying to think of like how would you organize, say, a queue processor that's only making sure they run 20 concurrent processes at a time down through a list of items to process. Is that difficult to do, or is that straightforward?
So mostly, in the general sense, mostly you don't think about it. So the VM
Mm.
handles it all for you. So it's going to do all of the work. So imagine that you have 20 cores and you're going to have some processes doing CPU work, and you're going to have some processes that need to talk to the database. It doesn't matter if that process is doing IO or CPU work, the VM just takes care of everything. And the
Mm.
processes, they are preemptive as well. So there's not like a process can go and hog all the CPU forever. They all get, I like to say, they all get some amount of gas, um, and they can do some amount of work. When that gas is done, they are scheduled out and they give opportunity for another process to run. So it's in many ways it resembles an operating system, with the isolation between processes and things being preemptive, and so in the general sense, you don't really need to worry about when things are going to run like the VM is well tuned for the huge majority of use cases. I bet the WhatsApp folks, they had to pass some flags to customize the runtime for their specific needs, but mostly you don't care. And then depending on the problem that you are solved, you're modeling everything using processes. So for example, what a web server, so we're talking about plug, and then you imagine you have a web server running Erlang. Every time there is a request, what you do is that you will start a new process to deal with that request. So in that case, there is like some orchestration because you have something listening on the socket to connect, and then you start separate processes to deal with requests. Or sometimes, imagine that you have a queue. It can even be an external queue. Imagine that you want to connect to SQS, and then you want to get work and then process that work with a parallelism of 4 entries, right? Then you're going to write one process that connects to SQS, and that process starts 4 other processes, and then it's giving it the data on a round trip randomly, whatever algorithm you choose. Then you implement the algorithm, but you don't really need to think about when is this running, right? If it has work to do, it will eventually, the VM is going to wake that thing up, and it's eventually going to do that work. And but if it doesn't have anything to do, it just sleeps. It stays there until something comes up.
And it also sounds like this might be interesting in terms of trying to debug applications like this and also testing. I'm wondering how debugging and testing works with Elixir.
Right. So debugging has, so there are some good news and some bad news. So one of the things is that a debugger can be a bit tricky in Elixir. Because, and now they are improving this because imagine that imagine you have 1,000 processes running at the same time, right? So, and you want to stop one. So you can stop that thing, and we could stop one, but what if something else is waiting on that one that stopped to send a message? So the thing, it doesn't get the response because you stopped it, and now that thing crashed, and then you have the supervisor who's going to say, hey, this thing crashed. Maybe I should restart this part of the system. So if you think like, it's really like in a way, so Joe Armstrong, one of the creators of Erlang, he had like some great quotes about object orientation, right? But one of his quotes was exactly like, I don't think, like they say they model the real world, and I don't think they model the real world at all, because the real world is really like concurrent entities, like people. Everybody have their own will, and they send messages to each other, right? And when you think about it, like it makes sense. Like in a world, like if I freeze somebody, a lot of things that thing depends on is going to stop working. So in recent versions of the Erlang Virtual Machine, they are now adding some like, okay, we really need to be able to stop everybody and stop the world for certain debugging problems. But testing is, because of immutability, each process has their own state. We have a lot of visibility into it and control over how things execute. So testing is definitely a plus. And again, like if you're writing the kind of like concurrent and distributed software, then it's amazing, right? Because testing the distribution in a lot of times, right? You just write the concurrent tests, you do a bunch of concurrent tests because the concurrent distribution mod is the same, and then you add some of the distribution tests as well. But that alleviates a lot that they are both solving the same problem.
And the VM, you're just using the standard Erlang VM for Elixir, right? You're not really have a modified version of it to do something special. So you're interoperable with everybody else that's doing Erlang.
You can call Erlang with no performance cost whatsoever. You don't need to translate data structures nor anything. We compile to the same bytecode. So, and that's usually the case for most, if not all, languages running on the Beam, that they interoperate very easily.
Can the beam run on bare metal? Because it seems like it's an operating system at some point, right?
So, oh, and I should clarify, Beam, because I think it's the first time I mentioned that word.
Yeah.
So the Erlang VM, right, is a specification. It has one implementation called Beam. So if you ever hear anybody saying Beam, it means Erlang VM, pretty much. Um, so for right now, we have Atom VM, which is an implementation of the Erlang VM to run on microcontrollers or to compile to WASM.
Ooh. Ooh.
And in the past, we did have Erlang on Zen for bare metal, and I know there is one company that has Erlang like really close to the bare metal because they run on Cell 4, which is like it's a mathematically verified to be safe, secure operating system kernel. So there are people bringing it to really run like bare metal, but I think you have work to do. I don't think you can get the Erlang VM as is if you want to run it on bare metal right now,
Okay.
right? You can run on any computer, but if you want like really, there is a word for this. What is the it's not kernel, but anyway, if you want it like to run like as the kernel, really bare metal, you need work. I don't remember exactly.
You thinking of
Yeah,
hypervisor?
okay.
Yes, thank you.
Yeah. Very good. I was going to ask what it looks like to run, so I'll modify that question a little bit. And what operating systems can you run the Elixir VM under? Is this a Linux thing?
All,
Can somebody put it on their MacBook? Does it work under Windows? What are we looking at?
yeah, it works on all the ones that you mentioned. Yeah.
Okay. And then I assume it can just you can mix and match those with the ability to run on multiple machines at once.
Yeah. Yes, exactly.
Yeah, very cool. Um, I remember we had a conversation with some folks that were doing Erlang and Elixir stuff down on like the Raspberry Pi with the Nerves process. I think
Yes.
it was called. Are you involved with
Yes.
that as well?
Yeah. So I'm not. So I mean, they are part of the community, and I know Frank and the people behind the Nerves project. And if they need a hand, I'll be more than happy to help. But I'm not involved in the day to day of the project.
Sure.
Right. So I think we can break very quickly like what you can use Elixir for, right? So it was going more into the more practical things. So I like to say. Based on everything that we said, everything that is running on top of a socket, anything that needs to do anything related to the network, Elixir is going to be excellent for, right? It's used a lot today for web apps with all kinds of complexity, complex ones like Discord. So if you use Discord, every time you send a message that is passing through Elixir machines, they're using Elixir for all the communication that they do. But if you wanted to build a regular web app, it's going to be great. And especially if you want to have any sort of real-time feature, real-time progress, anything that you say, look, I want to push information to the user. Elixir is just excellent for that because it all comes from Erlang and that ability to be able to handle um, millions of users at the same time. So for web, it's excellent, and I also like if you're going to talk a little bit about AI, I also like to say, like I said, like the telecommunication thing is really this when they built Erlang for telecommunication, everything is running concurrently, information is coming and going. That's the same as the web, and it turns out that it's actually the same as AI today, right? Because AIs, you have a bunch of agents running, they need to communicate, exchange message with each other, right? And the beautiful things, like there are folks building agentic systems with Elixir, right? And then
Wow.
if you have any other language, you have to do so much work because you have the agent running one place. Now you need to communicate with somebody else. You have to go put something in a queue, wait for something to get that thing from the queue, maybe communicate it back, right? And then you have all those pieces that can fail. And in Elixir, everything can just talk to each other, right? The humans can be in the loop if they want to communicate with agents. So anyway, agentic systems, web, that covers the biggest chunk of it. And then we have NURBS, which is about Raspberry Pi, embedded software, right? High-end, high-level embedded software,
Yeah.
which there's the NURBS community. And you probably talked with them and then they went into detail, but one of the things that attracted them to Elixir was, of course, also Erlang. Because if you're building embedded software, right? Like suddenly the Wi-Fi stops working, right? And when the Wi-Fi stops working at home, what do you usually do? We restart it, right? So they're like, well, we have, if you're writing embedded software, you have all those components, right, that they can fail at any time. So how are we going to reason about restarting those things? And when they look at Erlang, they're like, perfect fit, right? We also do, Elixir can also be used for machine learning. So a couple of years ago, we started making so that you can write Elixir code and compile it to run on the GPU. And
Nice.
so I like to say, like joking, like, you know, like Elixir can scale across cores, right, which is concurrency, can scale across machines, which is scaling horizontally, but it can also scale across GPUs because you can get Elixir and compare it to the GPU. There is the MainBrain framework, which is used for auto video processing, and there are probably a few others that I'm missing. But it's kind of fantastic, like from the Erlang virtual machine and this programming model that they had at the beginning, how it's still very general purpose, and we can apply to all of those different problems.
Well, I just typed brew install Elixir, and 30 seconds later, I've got an Elixir on my Mac, so I'll
Very
get to
cool.
play with it after the
Nice.
show.
Yeah, the AI work that you've done, is that related to what's going on at Tidewave?
So, yeah, so I mean, we can break it apart. So let's say, because AI is too ample, so we did a lot of AI machine learning in the sense that you can, you know, like you can get Elixir compiled to the GPU, you can get like a model like Qwen3, like you can get one of the open source models, and then we actually have the model implemented in Elixir. So you can go and run Qwen3 on your GPU with Elixir, and Elixir is going to coordinate the GPUs and everything. So all those things, they are part of AI, right? But that's part of the general open source platform, and everything is open source, numerical Elixir, and so on. There is a more recent effort that is closer to anti-gravity that we were having, like Google anti-gravity, that you were having at the beginning of the conversation, which is, I would say, it's related to Elixir because I am involved, but in many ways it's separate from Elixir, right? Like the commonality with Elixir, it's me, rather than it being an Elixir project per se. And most of it was me thinking about like looking at coding agents and thinking about, hey, I know the code agent is like trying to find information or trying to do something, and I know like the compiler has this information available. So how can we make coding agents smarter by like closing the gap between what the code agent's doing and what I know the compiler and the runtime have available for it. And I'm just going to give an example, and then I'm going to give it back to you so we can expand more on the questions. But like for me, like one example is like documentation. A lot of the time, like because we know that the agents, they are like the large language models, they are running outdated information that is usually like maybe a year ago, maybe 6 months ago. So sometimes they're going to use something, and then they're like, okay, I cannot use this thing. I guess I'm outdated. I need to go for the documentation. And then it goes and search the web. And then I'm like, that doesn't make sense. Like, if I am in the IDE, I have the documentation there, right? Like if I mouse over something. So it's hilarious that we are installing like MCPs. We are going to the internet to search, like the agents, they are searching for this information, but I have that information locally, right? Because it's on my machine, the code is running on my machine. I need to compile, I need to test it in whatever environment it is, and that applies like to a lot of things. Like sometimes the code agent is going to be like, oh, I need to search who is calling this function. Well, right, like the compiler knows who is calling that function, right? Oh, I want to know where I need to search where this thing is defined. Ask the language runtime. The language runtime knows where things are defined, right? So that's how I started with it. But I'm going to pause here and get your thoughts.
Yeah, that's actually really interesting. I like the idea that your compiler knows what's going on inside the program, and therefore your AI agent ought to as well. That seems like that's thinking in the right direction,
Yeah.
at least.
Yeah.
All right, let's see. What have we not asked you about that we should?
Yeah, so I can expand a bit more on the AI side of things
Yeah,
for us
sure.
to wrap it up. 'Cause-
Cool. Yeah,
so
definitely.
Tidewave, that's how. So when it started like that. It started with me thinking about, okay, what if we get all this information and make it available to the agent, right? Um, but as time passed and I started using agents more for coding, and I still do a lot of web development, I would have this like frustrating experiences. So for example, I would ask the coding agent to go and implement the feature, and then the agent would be like, blah, 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 okay, I'll go implement everything. And then the agent says, hey, it is working. And then I would open up the page in the browser and I would get an exception, right? But the agent did not see that I got an exception in the browser. So I had to go copy the exception in the browser to the agent, right? And so I felt like I was constantly doing things like, oh, I'm just moving information around. This is not fun at all. Like this is a very mechanical part of the job that I'm not enjoying. Or for example, imagine that you want to implement a feature. So uh, like imagine that you have a page, you have a dashboard, and you have to implement export to CSV. So when you are looking at the page, you are like naturally you're saying, oh, I see we have a drop down here, so I want to select this drop down and add a new button in there. So you look at the page, you know the changes you have to make, right? But your coding agent now is most likely running in the terminal or in the editor. So all that context, I am on this page, the agent doesn't have it, right? It's like it's a completely separate place. So what you have to do is that like, okay, so let me find where. So now you go to your editor, you search the file where the drop down could potentially be at, um, and then you have to search, and they're like, okay, agent, I want you to change this thing. So also again, like you have to kind of translate what you're seeing. You have like to translate the error message, translate what you see visually, and give that to the agent. So our insight was, what if we? And that's what we built with for Tidewave. So Tidewave, it's a paid product, so it's not open source, so it's part of my non-open source work. But it's a paid product that gets the coding agent and runs it in the browser, because we want the coding agent to be full stack. We want it to be able to. So in Tidewave, how I would solve this problem, like you open up your web app inside Tidewave, and then we have an inspector, and then you click the drop down and say, hey, I want you to add the export to CSV thing. And what Tidewave is going to do is that we get all the DOM information, but Tidewave also it correlates where that button is rendered on the page with the file, with the source file that it is in disk. So all that boring work that I was talking about, like, oh, you have to find the source, we do it automatically for you. And when there's an exception, the agent, because we're running in the browser, the agent automatically sees there's an exception and is going to fix it for you. So the idea is, and we try to make it everything full stack, because remember how I was saying, like, well, I want the agent to understand the language runtime, to understand where documentation comes from, where code is defined. So we connect the agent both to the UI and to the web framework that you're running on, like Phoenix, Rails, Next.js, Django. We connect them together so the agent like has visibility over everything. everything you're doing in the UI, even in the database. So if you're using Tidewave and you ask it to implement a feature, often it goes, implements the feature in the code, and then it's going to test it. It automatically coordinates things in the browser because we give it control of the browser running on your page. It's like, okay, I'm going to fill in the form. It fills in the form, and then it automatically goes and read from the database to see that we actually store the correct thing in the database. So the agent's full stack. It can understand everything. And that's part of like this idea where I think like today we have like it's kind of funny, right? Because a lot of people are like, hey, you're not going to need to write code anymore. And then everybody went and put the agents in the place where we write code. So you're like, which one is which? but
Yeah.
But for me,
I love
Yeah,
I
go
love
ahead.
the idea that you're trying to do AI and get rid of the busy work. Like that's the promise. That's been the promise of every office innovation for the last 100 years, right? It's going to get rid of the busy work, and so far here we are still all doing busy work. But I like it when a company, an idea, sort of looks at, okay, let's take this tool and actually get rid of the busy work and let people get back to really doing things. That's pretty cool.
Can I ask some questions about the actual project? So you got the Elixir project. Is that just a labor of love for you? Are there multiple people contributing to the core? How is that? How does that look from the top level view?
yeah. So today the Elixir core, it's definitely a labor of love, and also so when I started Elixir, I was one of six founders of a consultancy. And very early on, I was like, hey, can I go part time on this? And then they said yes. And then when it started getting traction, they agreed with me being full time. But it
That's awesome.
took 4.5 years from them allowing me to work on it first to get our first client. And like the first client was not like a big project. It was
Right.
like basically like a consultancy, like code review aspect. So I was also lucky. So it was a labor of love, but I was also very lucky that I had people uh, investing on the idea and investing on me since the beginning. We saw that consultancy 5 6 years ago, and that's when I started Dashbit, which is basically it is a consultancy, but we want to be small. We work with a selected amount of clients, and the idea is that we work with them, we help them do architectural decisions, write better code, and we get useful feedback so we can feed that into the language, into the ecosystem. So we create like several open source projects, and some of those come from watching our client needs and so on. So a labor of love, and the Elixir team has I think 4 or 5 people today, and they are not at Dashbit, right? They are also contributing their love and their time to the language. And then of course there's a whole ecosystem with a bunch of other projects like I mentioned, right? And those are different people, different companies involved.
Okay.
Very cool. What's the license that Elixir is under? It's usually something we
Apache
cover.
2.
Okay. Yep. Very cool. All right. We are getting down to the end of the show. I've got a couple of final questions I've got to ask. Before I get there, though, is there anything else about Elixir or your projects that we should have asked that we didn't get to?
Nothing comes to mind.
Okay. All right. So I've got to
Cool.
ask you. I've got to ask you then. What is your favorite text editor and scripting language?
Ooh, text editor. I love Zed. It's it it's kind of cliche. So, well, I'm trying to see how I'm going to describe Zed. But one of the things that I love about Zed is it doesn't get in the way. It's one of the ways about it. Like when I open, like when you see like the cabin of an airplane, and then you look at all those buttons, and you're like, how can they fly this thing? That's the same impression I get when I open VS Code. I was like, why there are so many buttons? Like just opening the thing, it feels like
Yeah.
it's
That
such a
some
big
days, yes.
cognitive load. Like I mean, like if it works for you, it's perfect. Like it's two, everybody finds the one, but just not for me. And Zed feels so smooth, so fast, right? Like sometimes I was used to say, of course it's a joke, right? But I was used to say like the thing would show up on the text. Like it's kind before I press the key. Like that's how fast it feels. Like I didn't press the key, and it's already there. But and it's one of the things where people like you say like that's bullshit. You're not. Oh, sorry. I don't know if you can. I
We
don't
try
know
not
if it's
to,
a
but that's
base
all right.
either. Yeah, sorry, but it's like but you feel it. You 100% feel it. Like when you go from something that like the lag when you are typing, it's very visible. And there are some features that I love, like multi buffers. So yeah, so Zed is my favorite editor.
Yeah,
And
and it
scripting language I use. Yeah, go ahead.
was just going to ask scripting language.
Elixir. You can totally run Elixir scripts, and then if you write Elixir as scripts, there is a chance that whatever problem you are solving, you can solve it concurrently as well. So depending on what you are doing, that's a huge boost.
Very cool. Can you do splat bang Elixir scripts?
Yeah, you
Oh,
can,
cool.
and we have this cool thing where if you need to depend on, so you can have like single files Elixir, like you can have Python and Ruby, and if you need to depend on packages on the ecosystem, you can do that as well. But for every time you run the script, we create like a consistent cached version of the environment that you want. So it's not like you are, so like many languages, they have this issue where you pass the script around, but in order to execute the script, you have to install 10 different things that are
Right.
not part of the script itself.
Right.
And in Elixir, you kind of have like this mini specification, and we are going to get everything for you, run the script in a separate environment. So it even has a benefit.
Yeah, very
Yeah.
cool.
Wow.
Very cool.
And is there a VS Code plugin for Elixir?
Yeah, we do have the language server extension and yeah.
Nice.
Very cool.
Nice.
Awesome. All right.
Definitely checking this out.
Yeah, Jose Valim, thank you so much for coming. It's been a blast to talk to you, and we sure appreciate it. Good to finally meet you in person and good to chat.
Yeah, thanks for having me.
Yep, great.
Yay.
All right, Randall, you are our sunshine now, aren't you?
And what's funny is I'm trying to look for the webcam settings and it's not popping up, so I can't even like dial this down. So I live in a basement. I live in a daylight basement, and you can tell it's a daylight basement because there's a one window that's 1 foot by 3 foot, and it just happens to be between me and the sun right now.
Yes.
So the sun is shining in, and I can't do anything about it. There's no blinds on it because it's just a tiny little window, and it would be my only daylight, my only existence of an outside world. And it just happens to hit right around this time of day, which affects my live streams on Wednesdays that I do typically
Yeah.
right about now. And so I'm just going to be blown out for a second. I can't figure out why the webcam settings isn't coming up as a pop-up so I can control my current setting. But
It's
usually the
fine.
question you're asking me at that point is, what do you think? What do you think, Randall?
Yeah.
This is, I tell you, like I said, I just installed this. I am going to go play with this. It seems like something that fits a nice niche.
Yep.
I wouldn't, run to it for everything necessarily, but it looks like it could be handy for certain operations that might be a lot of fun. I'm a functional programmer, so the idea of immutability and doing things that are sort of Haskell-like appeals to me as well. So that should be fun. I haven't taken too much of a look at the syntax, just whatever's on the Wikipedia page. So it looks a little Ruby-like, perhaps. I don't know. We'll have
Checks
to
out.
get into that. But that actually wasn't relevant to most of the conversation we had today. 'Cause,
Right.
I'm really glad that we got to sort of the overall big problem, big picture, what is it solving, kind of issues, and how it fits in the ecosystems and things like that. So, and the fact that I can install it with Brew was really nice.
Yeah, that's cool.
So I know I'm going to be able to play with that moving forward. So yeah, this was a good show.
Yeah,
It was fun.
absolutely. I appreciate you being here. Is there anything you want to plug? Let folks know about?
I'm available for office hours on Dart and Flutter. So if you
go.
want to sign up, just find me on any one of the Flutter socials, like the Discord or the Slack. Oh, I guess I forget way back here.
There you go.
See me now. There we go. Just I look like an old man way back here, though. I am an old man. That's the problem.
I wasn't going to say it.
I'm 64 now. In fact, I've been singing when I'm 64 all year for karaoke, and of course I sang it actually on my 64th birthday at karaoke, so that was a lot of fun.
That's great.
So I'm available for office hours. I'm also still looking for more Flutter long-term contracts as well. So if you're doing any kind of mobile development, or Flutter's also good for desktop. We're doing desktop stuff now. Please contact me for that, and also just watch for me on the socials, and watch for my daily food picture on Facebook as my proof of life, to make
Proof
sure
of
people
life.
know that I'm still around. Yes.
Awesome.
So yeah.
Well, it
all good.
was great to have you back today, and we will do it again. Appreciate it so much.
Thank you.
All right. We sure appreciate Hackaday being the home of Floss Weekly. If you want to find more of me, you can go check out the Untitled Linux Show. That is the other podcast we do over at twit.tv/ULS. Have a lot of fun there. It's more of a news of the week sort of show with analysis of what's going on in the Linux world, but would invite you to go and check it out. We appreciate everybody that's here. Thank you for those that watch, those that listen, whether you get us live or on the download, and we will be back next week on Floss Weekly. All right. Got it done.
Yeah, that was a fun show.
Yeah.
Fun show.
I liked it. Let's
Definitely.
see.
Now I got new things installed to go play with. It's like, great. Now I got to get distracted for the next 3 hours. Wonderful.
You didn't have anything
All good.
important to do
I hope you
anyways,
enjoyed.
right?
Apparently not. Yeah, more good luck to your success and everything, and hope everything works out for you. Glad you could come on the show today.
Yeah. I think
Thank
I'm
you,
going to
folks.
call it Elixir Origin Story. Their show
Yeah,
title.
that sounds good.
Yeah. A sort of a functional show title,
Yeah.
as opposed to a creative one.
As opposed to a dysfunctional one.
Well, yes, that too.
Well.
That too. All right. I will also
It
say
had
we
to
are
be
always
functional,
we are
given the
always
language.
looking for guests. So Jose, if you know somebody that you think needs to be on the show, let us know. We will get them scheduled.
It has to be about open source.
It's got to be open source.
Necessarily.
Yeah.
Yeah.
Yeah, it's an open source. The show is all about open source. So, yeah, we've had a couple of times somebody will come on and their main thing is a closed source project, and it just doesn't work very well. Like we did today, taking a couple of minutes and talking about something, that's fine. But like, if we wouldn't want to do the show all about the closed source solution.
Yeah. Sounds good.
Yep.
I will.
Okay,
Well,
I will edit today, and
Yeah.
it should go out tomorrow. I will
I
try
will-
to get you guys an email when that happens.
alrighty.
All right.
Perfect.
Thank you both.
All right, folks.
Bye.
Have a good one. Bye bye.
Bye.
Right.
All right. This is Floss Weekly, episode 860, recorded Tuesday, January the 13th. Elixir Origin Story. Hey folks, this week Randall joins me. We talk with Jose Valim about Elixir. In fact, we get its origin story. What was the problem we were originally trying to solve, and why is Elixir so interesting for today's problems, whether it be concurrency, the web, or even AI? You don't want to miss it, so stay tuned. This is Floss Weekly, episode 860, recorded Tuesday, January the 13th. Elixir Origin Story. All right, I think that'll do. Thank you, everybody. We'll see you next time. Bye.